Here we're going to have a look at the reduction of aldehydes and ketones. Firstly, the reducing agent for this reduction reaction. The reducing agent is a chemical called sodium tetrahydroborate, tetra meaning 4 hydrogens. We simplify that to a H in a square bracket. That represents my reducing agent, much in the same way as acidified potassium dichromate is represented by an O in a square bracket. Now, we're first going to have a look at aldehydes. And they are reduced to primary alcohols. I'm going to have a look at the reduction of we'll look at ethanol. Now, we actually need two H in square brackets here, because we're going to add one hydrogen here to this oxygen and the other hydrogen to the carbon bonded to the oxygen. And that's going to give us the following product. So I've added these two hydrogens here. Now, ketones, they're reduced to secondary alcohols. And we're going to look at the reduction of propanone. And again, we need two H in square brackets, and we're going to add one of the hydrogens here, the other hydrogen here. And that's going to give us the following product. And I've added my hydrogen here and my hydrogen there. Now, we need to know the mechanism for this reaction. Now, NaBH₄, this sodium tetrahydroborate, is a source of hydride ions, H- ion. Now, the mechanism of this reaction is as follows. And this is mechanism the same whether I'm using an aldehyde or a ketone. I'm going to use ethanol as my example. Now, the first thing to note is this is going to be attacked by this hydride ion because this carbonyl-carbon here is part of a polar bond. This here is a polar bond. We've got a much more electron-negative oxygen, so the electron density is going to be much more towards the oxygen, which is going to give us a delta plus charge on that carbon and a delta minus charge on that oxygen. And this hydride ion here, this negatively charged hydride ion, is going to be attracted to this delta plus carbon. So, what we're going to get then is this hydride ion with its negative charge, lone pair, that's going to form a bond here. So we're going to form a new hydrogen-carbon bond. In the process of this carbon-hydrogen bond forming, then we're going to have 5 bonds. So another bond has to break. And it's this carbon-oxygen bond here, one of the bonds in the double bond. Now, that's going to give us the following intermediate structure. Again, these curly arrows, what's the consequence of these curly arrows? Well, we can see that one of my carbon-oxygen bonds is broken. So now I've just got a single bond between the carbon and the oxygen. And I've added hydrogen. So this hydrogen here is now this hydrogen here. The pair of electrons that were in this bond have now gone towards this oxygen. So now this oxygen has now got a negative charge and a lone pair. So in effect, these 2 electrons here were the 2 electrons that were in this bond. What happens next is we add the second hydrogen. So remember, we've got to add 2 hydrogens. That's what the equation tells me. I'm adding 2 hydrogens. Well, there's 1 hydrogen here, and the other hydrogen is in the form of a hydrogen ion, a H+ ion. Now, we've got a curly arrow. Remember that the curly arrow, the base of that arrow has to start from a lone pair at the centre of a bond. So please do not do this, which I've seen many times. That cannot be true because this hydrogen ion doesn't have any electrons. So the base of an arrow can't start from something that's got no electrons. So the base of the arrow starts from the lone pair and it goes towards this hydrogen ion. And that there gives me my final products. Which is ethanol. Now, this mechanism has added a nucleophile. So the mechanism name is nucleophilic because it involves this nucleophile here, and it's an addition reaction. And remember that addition reactions involve double bonds going to single bonds. So we can see that in our reactants I've got double bonds, and in my products I've now only got single bonds, and that's what happens in an addition reaction. Double bonds go to single bonds. Now, we can see then from this reaction that it's the reverse of the oxidation we've looked at. So we can summarise these redox reactions as follows. Primary alcohols, they can be oxidised to aldehydes. And aldehydes in turn can be reduced to primary alcohols. Secondary alcohols, they can be oxidised to ketones, and ketones can be reduced to secondary alcohols. So that there is an overview of the redox reactions involving aldehydes and ketones. And that there is the reduction of aldehydes and ketones.